Hey everybody, Ugly Shader here with another YouTube video tutorial. And as I'm sure you can tell by the title, it's time to jump on into procedural texturing. Now, procedurally generated texture is kind of a complicated name for a relatively simple term. Um, Say this image right here that we have on our Blender splash screen or whatnot. Say we were to use this as a texture. Well, all Blender is going to do is determine the size of the area that the texture is going to be applied to, and then figure out how big basically each dot of color needs to be based on each pixel in this image, and then it's going to just make each dot on the object where the texture is supposed to be try to look as close as possible to each pixel in this image. So it's basically just looking at the image and copying that color and brightness information into a spot on an object. That's all using an image texture does in Blender. Well, procedurally generated texturing is essentially the same thing. It's just instead of using an image to tell Blender, well, this dot here needs to be this color, this brightness, this dot here needs to be this color, this brightness, so on and so forth, we get to pick what color and brightness the dots are going to be. That's the only difference. And, like, honestly, when it comes down to it, whether you're working in Blender or another 3D art application, it's very useful to be able to generate your own textures. The amount of time it takes to find just the right image, make sure that it's not copyrighted, that you're able to use it in commercial or whatever use you're after and everything like that, and then to get it perfect. You finally find the image that you're gonna use after a while of digging. It's a good image, but it needs some work, so you load it up into like GIMP or Photoshop or something, and then you spend some more time, adjusting color, trying to make it seamless or something like that. And then you rescale it so it's a good resolution for what you're after, and so on and so forth. That's a lot of time cooked away when you could have just created your own material. And procedurally generated materials have a lot of benefits. One of the biggest is that they're infinitely scalable. No matter how close you get the camera to that material, it's not going to pixelate. It's not going to lose its resolution. So that's one of the biggest benefits behind them. Another upside behind it is just, yeah, the freedom to manipulate the texture exactly how you want. A lot of you may be familiar with like Substance Painter, Substance Designer, stuff like that. That's basically procedurally generated texturing with a nice, friendly user interface. Um, as it turns out, though, Blender is actually capable of doing most of the things that like Substance is capable of doing. You just need a general understanding of the function of the node editor and how procedurally generated textures themselves are created. Now, unfortunately, when it comes to learning about procedurally generated texturing, a lot of it is either in text-based, reading documentation and such, or the videos that you do find that pertain to procedurally generated texturing kind of just jump right into it. They expect you already have a general understanding of the node editor, or, even know what a procedurally generated texture is, and that's not always, necessarily true or even fair to assume. So with any luck, this series will, you know, get you started, get you understanding just the basics of what a procedural texture is, which hopefully technically we've already covered. It's just us picking what the dots look like and how to set them up. The basics of the node editor and how to get familiar with this. In this particular tutorial, we're going to open up the node editor, kind of familiarize ourselves with it, start assembling a procedurally generated texture, and by the end of it, hopefully we will have something you can use as a crack texture. Cracks in a sidewalk, possibly cracks in like a peeling clay or paint surface, something like that. Now, the node group we're going to be assembling isn't mine. Like I didn't come up with it. It's actually one I learned out of a group on Facebook called Blender Procedural Texturing. Great group to be part of. There is a bit of a screening process. They want you to answer a couple questions. where do I need to put this node if I want this to happen, and so on and so forth. Relatively simple questions, and with any luck, by the time we're done with this series, you'll have no problems answering them. And them people can come up with some amazing textures, like hardwood that looks like actual hardwood, and no image is required, meaning that you can easily darken or brighten it from within Blender. You can change the wood grain however you'd like from within Blender. Nice, simple, fast, and easy. I guess that's one of the other really beneficial qualities behind a procedural texture is that it's destructible. You can manipulate it and change it quite easily and quite freely without having to worry about odd consequences of image distortion because you're using an image-based texture. All right, so let's go ahead and get into it. First things first, we don't really need our menus up here, so I'm going to go ahead and hit T to get rid of that one. And before I hit N to get rid of this one, let's start some screencast keys so that you can kind of follow along. I'm pretty sure I remember right, 64 and 128 are good numbers. I'm eventually going to have to save this startup file with that in there. And yeah, now I'll go ahead and hit N and get rid of that. So the two real things we need to get started is we're going to need an object to put our material on firstly. So let's just add a cube. I could click the add button, but I prefer hotkeys. I'm right now 2.8 has been in beta for like a month and a half, almost 2 months now, and I'm still really reluctant to switch over because well, part of why I loved Blender so much was that the interface for Blender, to me, very much so felt like it was designed by developers for developers. The interface itself has a really steep learning curve. It's oftentimes quite difficult to try and understand how it's put together. But once you get used to it, it's like the way the windows are set up and all the hotkeys and stuff. Once you get used to it, it's such a fast, powerful tool. Amazing piece of software. And unfortunately, I feel like in 2.8 they've changed the user interface drastically in what I feel is an attempt to try and get Maya and like 3ds Max users and stuff to convert over to Blender. And I understand their desire to do that. And don't get me wrong, I love the fact that Blender's constantly changing and improving. But I thought part of what made it so amazing was its user interface. And now they've like completely changed it. So for the foreseeable future, most of my tutorials will be done in 2.79 still, especially because 2.8 is still in beta. And thankfully, though, pretty much everything I cover should translate over to 2.8 without any problems at all, especially if you continue to use cycles. As I understand, there might still be some problems with some of the nodes in Eve or Eevee or whatever, but yeah, if you still use cycles, everything should translate over no problems. Anyhow, let's get started. Let's grab a plane to put this material we're going to put down on. And let's stretch that out to about there. And check in rendered view, yeah, we have no light. So let's add a sun lamp. And I'm going to give it, I guess I need this menu back open. I'm going to give it a little bit of an angle. I'm going to give it like a 45 and a negative 45, kind of a traditional. I tend to do that a lot sort of thing. Bump the strength of the light up a little bit. Now that's not really going to matter much because we're not really going to have any depth or anything in this material. No bump map, no displacement. Those will be in later episodes. I don't want to overwhelm you guys right off the bat. So yeah, here's our plane. Here's our environment. You know what? I'm going to give it a little bit of a, I guess kind of a daytime sky color. Just to make it a little softer on my eyes. I don't know. The gray may have been better, but maybe it's just the way my monitor's set up. All right, so here we have our object, and our object needs a material. Now, some of you may be in the habit of assigning your textures and materials through these tabs up here. Unfortunately, that's a really, really limited way to interact with Blender's material system. The best way you could possibly interact with Blender's material system is through the node editor. If you are one of those that uses these to assign your materials, try to kick that habit, just because going into the node editor you have a lot more power and potential. So I'm just going to drag this window over so that we have our 3D view and our a window that we can turn into our node editor. And I'll come down to this menu and select node editor. And then just like over here where we have T and N that can pull up those menus, we have T and N menus over here, but we're not going to work with them right now. We're not even going to worry about them. They contain lots of things that you probably won't even ever have to use, depending upon how complex your textures end up being and stuff like that. So here we have our node editor, and down here across the bottom we have standard sets of menus, just like we find in almost any Blender window, only they're, tailored to the node editor specifically. And just like coming up here, going to Material and click New, we have a new option right here. And it carries all of the same functions as you get in this option right here. And as you can see, as we added this, we even wound up with things appearing over here. But I'm going to switch that. Well, no, you know what? For those of you that do use this, you might actually be able to follow along a little bit in the sense of seeing changes that occur over here as I make changes to the material itself. But again, try not to rely on this too much. It's basically a really, really, really limited version of what we have going on over here. So when we added a new material, by default we got 2 nodes. One of them is pretty much required. This is our material output node. It has three places that we could plug things in. It has a surface, a volume, and a displacement. For this tutorial, we're not going to worry about volume or displacement. We're just going to be playing with the surface. There's a node currently plugged into it, and it is the Diffuse Shader node. It's like when you pick your surface over here, the Diffuse BSDF. That is this. And basically, you may have noticed that we have colored dots, and there's different colors. All dots that are green are shaders. Now, what a shader does is it takes information, particularly color, location, vector, just all these different pieces of information, and calculates it so that it will actually be an image, so that the color and the brightness and everything like that we pick actually shows up on its dot placement in our material, in our object. That's basically all our shaders are doing. And there are different kinds of shaders that carry different characteristics. This, a diffuse BSDF shader, is the easiest way to think of that is like matte, flat paint. Yes, it has color, but there's really no glossiness, no shininess, nothing like that. It's just flat color. Now, we can come down here and hit Add, or just like over here, we can use Shift-A to pull up our Add menu. And we have an entire category for shaders, and dang, there's a lot there, isn't there? A lot of them we're not going to worry about till later lessons. For now, all we're really going to worry about is our Diffuse BSDF, our Glossy, and the Glossy shader is exactly what it says. It's the glossiness of a color. You have, like, think of car paint. Car paint has color to it, but it's not exactly a flat matte color. It's a shiny color, reflects sunlight. If it's a really nice gloss, you can actually see a reflection in it in certain spots and stuff like that. Our glossy represents our reflective qualities. So for this particular example, the only 2 different kinds of shaders we're going to worry about are a glossy shader and a diffuse shader. And those are the only ones we'll play with. We might not even really play with the glossy shader, but we'll go ahead and plug it in just to see what it does here in a second. As is, though, we have our diffuse shader plugged in. And yeah, all it is doing is, right now Blender sees 4 vertices. And Blender is set up so that it draws a plane, an image. Technically that's not actually really there, but we can see it. It's drawing a plane between the vertices contained by the edges that are defined by the vertices. And all that plane is a series of little tiny dots. Those dots have color information and brightness information. This is telling it what its color information and brightness information is. We can click on this box and it brings up a color wheel. And we have our choice of standard RGB coloring with an alpha channel, which we're not going to play with. We have hue, saturation, and value if you prefer viewing colors in that spectrum setup. And we have hexadecimal code. So if you have a specific color that you want to use, like caterpillar yellow, or John Deere green. Why am I thinking of just tractors? You know what? Honestly, that's because I just can't really think of any colors that are drastically associated with brands, I guess. I guess like Ferrari red, I guess, would be a specific color that you can look up online and actually find a hexadecimal code for, so that you can use that exact color. And regardless of which one you choose, above it you have your option of a color wheel. And this basically represents your red, green, blue, and this would be your alpha or your value, your brightness. So since we're right here in the middle, we're on white. We have white to black. Black is basically white without any color, or without any light value to it. So yeah. And then we can just drag this point around, and as you can see, our plane changes. Now, mind you, this is really basic stuff. I'm sorry if you're like, duh, this is obvious, but there are those out there who have never touched the node editor. And this is for them, you know? Anyhow, so that is basically all a procedurally generated texture is. We are just telling it what dots to have what color and what brightness. And a lot of the nodes have extra options, like we have a roughness right here. Now you're not going to be able to see much difference with just the diffuse, but as you can see, as I increase the roughness, it's almost like the material is absorbing a little bit more of that light that's hitting it. So where the light's hitting it at a slightly sharper angle, it's just not as bright. And that becomes more apparent as I increase that roughness. The roughness value is much more obvious in the Glossy Shader. Now here's our Glossy Shader, and that's basically like a mirror. Now, traditionally, you leave the color of the Glossy Shader white, because in the real world, glossiness normally doesn't have color to it. It's just the glossiness, it's the shine. The color is represented by the material underneath, but the shine itself generally doesn't have color to it. There are some exceptions, I guess, you know, like when it comes to metals. A metal surface that the metal itself actually has color, well then its reflection, the glossiness, the light reflecting off of that will also carry color. One second, I'm going to take a drink. So yeah, more often than not, when using a glossy shader, unless it's on a metal surface in which the metal itself has a different color, you normally leave the color of a gloss at white. Now by default, the white isn't quite full strength. You can see down here we're at basically 80% strength. Because white, green, and blue mixed together in equal values, or sorry, red, green, and blue mixed together in equal values is white when represented as light-based color. So all of these being at equal values, but at 0.8, basically we're at 80% brightness. We can bring that brightness all the way up, and it actually enhances the glossiness a little bit, but a lot of people just leave it as is. Now, as I said, the glossy node makes the roughness a lot more apparent. If I bring this roughness up, we lose almost all of that reflective sheen it had. Whereas down here at the 0.2-ish that it's default at, we can actually see our sun blindingly like glaring across that surface. And in order to get a completely mirrored surface, we can take the roughness all the way out. And you actually don't see it anymore because there's nothing in the background to reflect. So it's reflecting just the background itself, and therefore it blends in. I didn't mean to add a plane, I meant to add a cube. So if I add a cube and raise that cube up, now you can actually see the cube being reflected in that surface underneath. If I select that again and add a bit of roughness to it, See, unfortunately, we got a lot of noise going on right here, but yeah, you can still kind of see that cube reflected in the surface. So yeah, a mirror, a procedural mirror is pretty much just going to be a glossy shader that has no roughness to it. Now, mind you, procedural textures, materials can be as complicated as you want, and you will come to find that the more you understand about them, the easier it is to make a very, very complicated material without much effort. Like honestly, it's a very, very simple process that these are based off of. And yeah, we're actually going to get rid of this glossy and go back to this diffuse, and this is going to be the only thing we use for our shaders. And yeah, to get rid of that, I just pressed X, kind of like deleting an object only here over in the 3D view window, but it doesn't ask you if you want to delete it. It just gets rid of it. So watch that X key and be ready for a Control Z on occasion if you bump something. Anyhow, so what we're going to do is, as I said, we're going to go ahead and put a crack sort of kind of texture on this. And again, this is going to be very basic. We're not going to go very in-depth with things, but we are going to touch on several of the concepts that are used for procedurally generated textures, particularly default base textures and math. Now, I know that that second one's kind of a bad word for a lot of people, but thankfully Blender really takes care of a lot of the complicated math, and once you really start playing around here in the node editor, you'll end up finding out that some of the coolest textures you've seen you created by basically using mathematical formulas you didn't understand, by just adding nodes that have certain math functions and letting Blender figure the numbers out and you just looking at what happens. And honestly, that's some of the funnest ways to work with procedurally generated textures. And over time, through playing around or through seeing how other people create their textures, you start to learn certain ways that you can easily create certain textures. The one we're going to be creating is technically really simple, but because we're learning about it, we're going to go through the various steps used to create it. So the first thing we're going to do is we need to add a texture. Um, Technically, this is a texture in a sense. It's color, it's represented, but for Blender's purposes, we refer to this as a material. Now, normally, when people add textures, they add image textures. They dig around online or go take a photograph and then to take that picture and put it into an image editor and clean it up and make it what they want it to be. And then they'll come into this area here where they have their diffuse BSDF and their material output, and they will add another node, and they will grab it out of this textures category. Ooh, and what they will add is an image texture. And again, you can do the same thing over here in the materials tab by, actually, I don't even know how you add an image texture over here. I have to admit, I don't use this tab. I watched 2 or 3 videos on Blender before I ever started using Blender, and 2 of the videos I watched, they set stuff up through here. And the third video out of the 3 that I watched, not in that order, of course, but they used nodes. And watching them assemble a texture out of nodes, though it didn't seem quite as simple as what was going on over here, it looked incredible. Like the ability to manipulate it and change things and everything looked like it was just so much better. So I didn't even really learn how to do stuff over here. Sorry, guys. Anyhow, so they'd add an image texture and they'd plug their image texture into the diffuse. Now, you see we went purple here, and that's the default color if you don't have an image selected. And yeah, all you do is you open a drive up and select an image, and that's how you use an image texture. Now, however, there is one other thing that you need to use when using textures. And technically, we're going to use it even though we don't have to, and I'll explain why. But it's this input down here, this blue one or purple one, however it shows up on your screen. It's called a vector. And basically, this is the map. It's the guide. It's what tells Blender where the texture is supposed to show up. Is it supposed to show up just up here? Is it supposed to show up over the whole thing? How, what's its default scale supposed to be? Is it supposed to be stretched out? So on and so forth. Where is the texture supposed to show up? That's what a vector is. Now you'll see this also has a blue dot, but it's called a normal. Technically, it uses similar information to figure things out, but it does something different. So let's not worry about that. Let's just worry about the one called vector. And a vector is more often than not determined by a texture coordinate node. That's up here in the input category. And that kind of makes sense because it's like the beginning of the chain. This is where the image is supposed to be. This is where we're going to place the image. This is the image we're placing. This is what takes all the crap that we've piled together and turns it into something Blender can actually use. And this is Blender taking what it can actually use and putting it on our object. So when you look at it that way, it's actually really simple. It's just one step after another. And yeah, if you've UV unwrapped your object, you'd use UV coordinates. If you want default object coordinates, you'd use object. If you wanted just default generated coordinates based on just how Blender does things, you'd use generated coordinates. And then, of course, as you see, you have a few other options. For all intents and purposes, right now we are just going to use generated because technically that is Blender's default. And I will explain that now. So since we're not using an image, we want to make our own image. We don't want that node. We're going to go into textures and we're going to grab one of the textures that Blender automatically gives us just by default. Okay, so now there's some that we don't really use. An environment texture, that's generally something you'd use for your background, not for an object. And that's a whole different lesson. Trust me, we got some lessons to cover where we can create our own backgrounds, beautiful skies that can be animated and everything like that. But those are different lessons. So yeah, we won't play with the environment texture. And the sky texture is very, very similar. The sky texture is Blender's default procedurally generated sky. And we'll actually probably use some of those when making our own sky texture, but our sky texture will be way cooler than their default. And then, of course, there was the image texture that we used. We won't use that. And the image sequence texture, which is very similar to the image texture, but, obviously it's a sequence of images, as well as the multiple images. Those are textures we're not going to mess with. Multiple images, image sequence, environment, so on, the sky, and yeah, the image. All of these other ones, the brick, the checker, the gradient, the magic, the moose graph, noise, the actually, I don't think we're going to use the point density either. Sorry, I kind of forgot that one. Anyway, the wave, and I'll save this one for last because I don't actually know how to properly pronounce it. Like, if I had to guess, I would say Voronoi, but I could think of like probably 10 other ways you could pronounce that based off how it's spelled. So, yeah. Anyway, so these are all fair game. We'll start with the checker texture because that's the easiest to understand. So let's throw this texture in here. Now, as I said, we're going to be using the generated coordinates, so we'll plug those into the vector. And we will plug its color, which is nicely named color for us. And anytime we are using color information, color-based information, I had told you a minute ago that these green ones were shaders. That anything that was a green output or a green input is what Blender recognizes as a shader, and a shader again is basically a computer code that turns our information into something that can be projected onto the screen. So all green ones are shaders. A green one has to attach to a green one, and that's where the limitations stop. Blue ones can attach to gray ones can attach to yellow ones can attach to blue ones. None of that stuff really matters. I mean, technically, I guess it's not supposed to, but because of how technically it's all based off of computer code and math and stuff, we can fudge the details a little bit. But yeah, when it comes to green, green has to attach to green. These can attach to any of these, but they do have specific indications. Gray represents more or less mathematical information, ones and zeros and everything in between. Yellow represents color information. So anything that's an RGB with a value mix, brightness and color. That is always pretty much yellow. And blues represent, as I said, vector information. And obviously this is a normal, but technically a normal is controlled by similar information as vector information. Once we reach a certain point in these lessons, there's a tutorial video that I've already done that I will link in one of the tutorials as far as creating your own mapping node, which is a node we haven't looked at yet, and we'll get to it 2 lessons or so from now. But the mapping node or whatnot is really cool, but it needs more functionality. And through watching some videos and reading some documentation, I learned how to create a customizable mapping node, I guess. And basically, through watching that video, you learn that Blender controls its vector information with basically a series of colors. So in a sense, these blue ones are also color information, but not standard color information. And we can actually show that by taking this blue one here that is the generated texture coordinate node and plugging it into the color input on our diffuse shader. And as I said, we can interchange all of these. Technically, I don't think they're supposed to, but because of how Blender works, it works. It's just green have to attach to green. That is a rule, that is a limitation. If you try to attach something like this to your material output, you get nothing. It does not work. You have to run green to green. Anyways, yeah, so if we run this generated texture coordinates into this color, as you can see, we have this almost really pretty colored rainbow running across that. And yeah, that's because location information, scale information, and everything like that for the image is controlled through color. So yeah, that's kind of a weird quirk about Blender. Anyways, back to what we were doing. We have our diffuse shader and we have our checker texture. And we'll plug that generated back into there. And we have 2 outputs here. We have color information and a factor. And then we have some inputs here. The scale of our texture and the colors of our texture. So if we plug this color output on our checker texture into the input on our diffuse shader, there's our checker. You know, it's just a checkerboard. And its colors are controlled by these color selectors. So we have ourselves a checkerboard. And the scale, as you could expect, increases the scale of the image. And yeah, just by default, it's a 5. And basically, yeah, there you go. There's a procedurally generated checkerboard. It's green and red and looks really funny, but that is a procedurally generated texture. As I said, it's a really complicated name for a really simple concept. Instead of using an image to pick where things appear, we ourselves are picking where things appear. And mind you, this is ridiculously simple, but this is how it starts. This is how you learn. This is the basics of it. So here we have our checker texture and its colors are, working right. But we have another output here, a factor output. Well, as I said before, this is basically represented as mathematical information. Now, when it comes to color, when it comes to the RGB scale of color, if we look at that in mathematical information, well, 1 is white and 0 is black. That's pretty simple, right? Well, because of that, if we use this mathematical information to control the color, well, we don't have color anymore because it's not actually sending color data out. It's sending math out. It's sending ones and zeros and, everything in between, basically. And since 1 represents white and black represents, or 0 represents black, we can still get our checkered pattern out of this simply by telling it 1 and 0, white and black. And that's one of the features behind procedural generated textures that through these lessons we'll actually use a lot of. But we'll get into that later. So let's go ahead and cut this off. And sorry, I didn't tell you how to do that. You hold Control down, and while holding Control, you left click and hold your left click down, and you can draw a little line, and it will cut through any noodles that the line goes through and destroy those noodles. These are your noodles, the little lines that connect one node to another. Everybody calls them noodles. Alright, so that's basically how a procedurally generated texture works. And one other thing to note is that on these default textures that Blender gives us, just the ones that are just pre-made for us, we don't actually need this texture coordinate node, as I said earlier. This vector input has information in it already in these pre-built nodes that Blender gives us. And the information that it carries is the same information that comes out of this generated output. So if I plug this back in, yeah, we still have our checker texture, even though we're not controlling the vector on it. So yeah, that's one other thing to keep in mind, that when you're using these default textures, unless you need to directly manipulate its coordinates, you don't have to worry about a texture coordinate node. Alright, so let's get rid of that and let's build this crack texture. Alright, so we've gone over the material output, the shaders, more or less, well, two shaders, but there's a general idea of shaders. You know, basically it tells Blender how to represent that information, whether it's shiny or, you know, flat color, and yeah, there's a bunch of them. So what we're going to do is we're going to put a different texture in, and we're going to put a noise texture in. And by default, the noise texture is very multicolored. And for our cracks, we don't want multicolored, we just want black and white. So we're going to use the factor output instead of the color output. And as you can see, it's literally done just what the node says it does. It's noise. It's just, you know, random scattered noise, a mixture of this white to black and everything in between. One way to get a better view of it would to be increase the contrast of it, and Blender actually gives us a node for that. So let's add a node, and here in the color category we have a brightness contrast node. So if we just bring this up here in between this noodle and drop it, it automatically attaches it for us, which is really handy. And we can increase the contrast on that, and as we do that, you can see that the dark is becoming darker and the white is becoming whiter, even brighter than it was before. And we can increase that contrast all the way up to the point that there's almost no gray left over. It's either just super, super bright white or super dark black, kind of looking like cow spots or something. Now, there's actually another way that we can control this mix between the white and black and how much gray is left over behind. And I think it has a lot more control than just adjusting the brightness or contrast. So let's go ahead and delete that node out, connect our factor back across, and the node I'm referring to is a color ramp node. And that is in the converter category. Right here. And drop that in. So now we have a factor input and a color and an alpha output. I don't really ever use the alpha output. I don't know if we'll worry about that in any of the tutorials I go over, but for now the important thing we're going to deal with is just the color output. And basically all this is it's just a black and white scale, and this represents how much black is in the image. This represents how much white is in the image, and the space in between them represents how much gray, anywhere in between the black and white, how much gray is in the image. So if we grab this one and bring it up, we actually increase the amount of black that's in the image. And by doing so, technically we're decreasing the amount of gray that can be there, because some of what was gray has now turned dark black. If we bring this down, we're increasing the amount of white in the image, and just like last time, decreasing the amount of gray available in the image, because the more white we have, the less room there is for gray. So yeah, This slider tells us how much black we have in the image. This slider controls how much white we have in the image. And the space in between them determines how much room there is for gray in the image. I love color ramps. You can use them for lots of features. In some later tutorials for this, we're going to get into using these and adding extra ramps to them, adding colors to them, so on and so forth. We're going to have lots of fun with color ramps. They're a very, very useful tool. For now, though, we're not going to use a color ramp. We're going to use math. This right here, this noise texture, this very, very light emptiness, just kind of mixed white, gray, and black, is going to be cracks by the time we're done with it. So there's a few things we need to do to it. The first thing we're going to do to it is math. Well, the only thing we're going to do to it is math. So we're going to add a node, and in that converter category, we actually have a node for math. And these nodes are awesome. They have 2 inputs, 1 output. We're not going to worry about clamp for right now. Just try to ignore that. But yeah, it's got 2 inputs, 2 outputs, or sorry, two inputs, 1 output, and a selector. And the selector is beautiful. We can switch this node so that it takes the 2 inputs and performs a mathematical function. Right now it's set to add, so it's going to add 0.5 to 0.5, and therefore the output is going to be 1. You know, we can all do that math, right? Half plus half equals a whole. But yeah, we have subtract, multiply, divide, sine, cosine, tangent, arc sine. There's just a whole list. Mins, max, less than, greater than. So yeah, we have lots of mathematical functions that we can play with. And like I said, some of the most entertaining materials you'll end up coming up with are ones where you don't actually understand the mathematical formula you're building. You're just adding math nodes here and there and watching what happens. And through that, finding really cool materials. Anyway, so for this particular material, we are going to take the subtraction node. And we're going to drop this in right here. And as you can see, we got really dark. And that's because, again, black is 0, white is 1. We just took the original... Oh, that's not what I wanted to do. I was going to zoom out a little bit. We just took this original image, and for every single spot that Blender is giving us color and brightness information, for every last dot, every last pixel that makes up this image, we just took all those 1 to 0 values and subtracted 0.5 from them. So if it was a 0.6, well, now it's a 0.1 and almost black. If it was anything 0.5 or lower, well, we have subtracted it so far down that now it's all black. So that's what that node has just done. It has subtracted 0.5 from every possible value for every single pixel on this image. Now what we're going to do is we're going to make another one, and we can duplicate things just like we can in the 3D view window by holding Shift and pressing D. So now we've made another one. Let's plug the factor into this one, only let's plug the factor into the bottom of this one. So now we have 2 subtraction nodes, and they both have the same value being input into them. However, they're performing different formulas that are going to have different answers. Right here, we have a number minus 0.5. So yeah, say we have 0.6. Well, we have 0.6 minus 0.5. The answer will be 0.1. But here, we have the exact opposite of that. We have 0.5 minus a number. So here, where the answer would be 0.1, if this was 0.6 minus 0.5, here 0.5 minus 0.6, instead of 0.1, we have negative 0.1. So simply by moving to the bottom input on a subtraction problem, we're actually doing a different problem, because the order that we do our problem in matters, 10 minus 5 is a different problem than 5 minus 10. So because of that, we can actually get a different result. And as you can see, it's almost an inverted result. It's almost perfectly inverted. only it should be off by just a little bit. That or it is perfectly inverted and our off comes from the next step. I can't remember. Anyway, so we have two inverted options, or two different images here, and one's pretty much the opposite of the other simply because of how we did our math. Well, let's do a little more math. Let's grab this node and duplicate it and drop it right here. And instead of subtract, we're going to set this one to a maximum node. Now what this is going to do, this is a comparative node basically. It's going to look at this input, and it's going to look at this input, and what it's going to send out for each and every dot that it looks at, because it's going to look at every pixel one at a time and do the math for every pixel one at a time. And for each and every dot it looks at, it's going to look at the answer for that dot. So say this dot right here, this imaginary dot right here, had a value of 0.4. Well, that means on this output, it's going to send out a negative 0.1. On this output, it's going to send out a positive 0.1. This node is going to compare both of those outputs and say, hey, this one's bigger. This is a positive 0.1, that's a negative 0.1. This output has this input has a higher value. And then for that imaginary dot that it just ran the calculation for, it's going to send out the positive 0.1 because that was the higher value. That was the maximum value. So it's going to run the equations for every single possible dot that will be our image, and it's going to pick the higher value of the two and send that one along the line. And for a quick glimpse at that, we get this. And as you can see, it's basically taken our negative and our positive versions of the image, mashed them together, and given us this image that's just got this very, very dark borderline where our negative and positive used to come together, and we're back to kind of just a mush of gray in between. So we're already starting to see that defined crack. But what we want to do for this particular type of crack pattern, I mean, this would be great for like a marble or something like that. But for this particular crack pattern, we want to get rid of all this noise in between. And because we know that black is 0, that means all this noise in between is going to be a higher value than 0. So what we can do is let's add us another math node, and for this math node, let's set it to less than. And we're going to bypass it so we can go back to looking at what we had originally. So basically we know that all of this super dark black is 0, and all of this stuff that's not black is somewhere above 0. Somewhere above 0 working its way towards 1. So that means that we can take this output, this image here, and use this math node set to less than, and we could tell Blender to only show on the image, only project what is less than a certain value. And if we set it low enough, it's not going to show all of this stuff that's gray because it won't be close enough to 0. It'll be above whatever value we set here, so Blender won't show that. So if we go ahead and set this, say, to, let's go 0.1. 0.1. Any value that is above 0.1, Blender is not going to show. So let's plug that in. And wow, that's not exactly what I was hoping for. Let's go ahead and try dropping that down a bit further. Let's go 0.01. That's getting a little bit closer, but unfortunately we're kind of inverted. I want the cracks to be black and the color to be white. Actually, I don't know what I want these colors to be. So instead of worrying about inverting that so that it was, white here and black on the cracks or something like that, How about we set it up so that we can pick colors? So if I cut this off and we just go back to that, I'll open this up, and in our color category, we have a mix RGB. And this is also a really handy node, and it's a great way to teach you about the factor. So if I plug this into here, and we'll just leave it on its mix setting, and let's go green with that color, and something really, really horribly contrasting. Oh, that's such a nasty color. That's perfect. We'll go red for that color. Basically, what this node is doing is it is mixing these two colors together at a factor of 50%. We have half green, half red, and that horrid puke color is what we get out of it. Well, because that's such a horrid color, let's say if we go a little more towards red. Now we're almost getting kind of like a burnt orange color. And currently, what we have is 80% red and 20% green. We can move its factor back the other way. Oh, didn't mean to right click. Oh, I just did a whole bunch of stuff all at once. Get rid of you. All right, so we can drag and move this back towards the green, and if we stop at, say, like 2, now we have 80% green and 20% red. Basically, the factor all the way at 0 is all the top input. The factor all the way at 1 is all the bottom input. See, and now, depending upon how well you're paying attention, you might be noticing a trend. This factor allows us to control the mix of color, and it happens to be on a 0 to 1 scale. Pretty much the same thing that we've been working on this whole time, this whole 0 equals black, 1 equals white principle. So what we can do is we can actually pick, oh, I'm zoomed in too far. If you're zoomed in too far, when you click on a color, you don't get the color wheel. It's like a, oh, well, I got it that time. I guess if I drag the node further up so there isn't enough room in the screen, well, I got it that time too. Well, I don't know how to do it, dang it. I've had it pop up so many, oh, there we go. See, so if you're, I guess, at the right angle and zoomed in too far, you don't actually get the color wheel. So watch out for that. Anyway, so if we set this color to white in hopes that this is the main background of the plane, and we set this color to black, we can actually use the output color from this little thing we've put together here, this black and white setup. We can actually use this output color, or technically it's an output value, just ones and zeros. We can actually use this to control the factor on this mix node. And when we do that, bam, there we go. Because all of this area on our original image was black, this is showing up as a 0, which is the top color in our controllable factor. Remember, if this isn't here, 0 is our white, or our top color, and black is our bottom color. Well, because this is the image we're using to control the factor, it's going to tell Blender that everywhere it's black, aka 0, put this color, and everywhere it's white, aka 1, put this color. And technically that's kind of confusing because our colors are black and white, but I can change that really fast for you. Hey, come on, open up. Oh, I guess it needs some value to it. So yeah, everywhere that this image is black, use our orange color. Everywhere that this image is white, use our purple color. So we are now using this image that we created to control the placement of color on our object. And that right there, that is the epitome, that is the goal, the focus, and the main point behind procedurally generated textures. Instead of just using a simple image, we created some sort of pattern, some sort of design, basically our own image. We then made it black and white, and we are now using it to control the placement of colors. So had we started with like a brick texture, we may have done the outline of floor paneling for a hardwood floor instead of cracks. And now, mind you, these are kind of sloppy cracks, like cartoon style cracks. If we wanted nicer cracks, we could come over here to our noise texture and we can actually increase the detail of our cracks. And now look at those cracks. Now we got like real actual detailed cracks going on. We can also adjust the scale. We can adjust the distortion and bend the cracks up for like, I don't know, some sort of like weird flaking metal or something. I don't know. But yeah, so you have controllable values on a lot of your textures that can allow you to add an additional edge to what it is you're producing. But there you go. There's a basic rundown on procedurally generated textures. Hopefully I didn't go too fast. I did bust out these math nodes, which a lot of people actually probably don't get to right away in procedurally generated textures, but unfortunately, they can be probably one of the most powerful tools in your procedural library. So getting to them, early, fast, and getting to them often can go a long ways into helping you get better at your procedural textures. Again, this particular node setup right here, I did not come up with on my own. It was one that popped up. It was probably one of the first ones I saw when I joined that Blender procedural texture group on Facebook. And yeah, it's a delightful node. I end up using it, node group, I guess. I end up using it far more often than I should. And yeah, all in all, basically pretty much everything behind procedural textures just starts at the beginning with what kind of, I guess, look you want your material to have, whether it's just a flat color, it's got some shininess to it, it's got transparency, or it looks like glass, it glows. All of these different shaders basically add different characteristics. Like, yeah, the emission shader makes things glow. We went over the diffuse, BSDF, and the glossy. There's a velvet shader that makes things kind of almost absorb light and stuff like that. So the actual characteristic or property of your material is going to be determined by your shader, and then what your shader, what your material looks like before the shaders is 100% up to your imagination. Again, this was a very, very, very basic procedural texture, and as these lessons go on, we'll start learning about more and more features, more and more different ways that you can manipulate uh, textures and patterns to create basically exactly anything you can imagine, any kind of texture you could dream up. Once you're familiar enough with nodes, you can simply just create just by throwing nodes down. And even though some node networks get really, really large and look complex, if you start at the beginning and learn how to build your textures, they actually begin to look incredibly simple. Because something like this, you'd look at a node group and be like, oh, a noise texture and a series of math nodes. Well, they're just using those math nodes to do something to the noise texture, and you could just sit there and play with the math nodes and see what effect they're having. So yeah, once you really start to learn the different ways that procedural textures are put together, it becomes super, super easy to just look at one and understand what's going on. Well, I think that should wrap it up for this particular lesson. Hopefully I didn't ramble too much. I'm sure I did. I'm a huge, huge fan of procedurally generated textures. It's been one of my biggest focuses while learning Blender, so I imagine this particular series is going to be even extra long-winded compared to my others, and I'm sorry for that, especially for you new people and those with limited patience, I guess. Anyhow, again, yeah, I hope you learned something from this. I hope you come back for the next video and continue to learn about procedurally generated textures and improve your Blender and skills. In the meantime, good luck with any projects you guys are working on, and Until next time, enjoy creating things your way.